A heavy uniform trapdoor is hinged to the floor. It is held opened by a rope as shown, which arrow shows the direction of the reaction force of the hinge on the trapdoor. Let's consider forces acting on this trapdoor. Its weight is in the middle because it's a uniform trapdoor and is directed downwards. Tension in this direction and the reaction force at this point. And there are two ways how to solve this problem, and the first way is the next. There is such a property that three forces in equilibrium meet at a point. So you can see that point of intersection of this force, which is weight and tension, is somewhere here. So this force, the reaction force, also should intersect at this point or its extension. So we can deduce that it's B. I repeat that three forces in equilibrium meet at a point: weight or its extension, tension, and this reaction force at this point. So it's B. Another way how to solve this problem: just consider translational equilibrium and rotational equilibrium and the corresponding equations. Since this object is in equilibrium, it means that it's in translational equilibrium. What does it mean? It means that the net force is equal to 0, or the vector sum of all forces is equal to 0, or all forces are balanced in all directions. And we can see that tension has component has horizontal component to the left, weight is vertical, force it has 0 horizontal component, and if we consider A, you can see that A has a horizontal component of this force to the left, and we can see that there would be a resultant force to the left, which is not true because this object is in equilibrium. Horizontal component or net horizontal force should be 0, so it cannot be A. So we can eliminate A, but we cannot choose between B, C, D. And then we can consider rotational equilibrium, and object to be in rotational equilibrium, torques or moments of force are balanced. It means that clockwise moments are balanced by anti-clockwise moments, and it's useful to consider this point where weight acts as a pivot, and we can see that there is torque or moment of force of this tension, which is what anti-clockwise. And to be in rotational equilibrium, there must be also what, not also, there must be balancing clockwise moment of force. And you can see that C and D, C or D will provide what? Also anti-clockwise moments, and if it would be C or D, you can see that there will be non-zero resultant torque or moment of force, and it would be in anti-clockwise direction, so it will not be balanced. And if we consider force to be B, you can see that B provides clockwise torque or moment of force, and this anti-clockwise moment will be balanced by this clockwise moment, and since it's the only clockwise moment, we can conclude that the reaction force is B. So the required reaction force is B. And that's all for this question.